Hey guys, welcome back to Algos Explained. My name is David Kim, and I have been pretty busy, and I probably will be busy throughout the rest of the year. Not much of the year left, but being the end of the year, what projects and stuff due and whatnot. So look forward to more of these screen recording videos. I would love to do more of the whiteboard ones, but uh, given that I'm strapped for time. I will be making more of these and probably more of the easier ones also. Of course, if you have specific questions on LeetCode or anything else in general, email me at algosexplained@gmail.com. And if you have emailed me before, fair warning, I don't have anything there right now. It's just been so long since I've stopped uploading videos, and now I'm back to it. So please email me again of your question or whatnot. Hopefully, if you had emailed me a question during that time period, you're good by now. But anyways, let's go to this question. How I'm going to structure these videos is we're going to read the question, we're going to talk about strategy, and then number two, we're going to go over the solution, and then number three, we're going to talk about why I chose those, probably within number two, why and maybe alternative solutions throughout this, for this question. And usually I say after I give you guys the solution to go ahead and go see if you understand it. But I realize that that's kind of a disservice, because if you didn't get to that solution, just seeing the solution itself is not really going to help you. You have to know why. And during my explanation of the solutions, that's when I really talk about why I chose one method over the other, or why one strategy came into my head rather than anything else. And so yeah, I encourage you to stick around for all of that now. But without further ado, let's go to the question. This is a two-sum. Number one, the first question on LeetCode, I guess. Yeah, an easy problem. And let's see. Half of the people who submitted are accepted. Okay, given an array of integers, return indices of the two numbers that such that they add up to a specific target. You may assume that each input would have exactly one solution. That's really nice. And you may not use the same element twice. Okay, so why I say that this is nice is because, well, it just answers one of the other questions that you might have asked your interviewer or whatever. Your interviewer, asking them, okay, can there be multiple solutions? And if there are, do you want all of them, or do you want just one of them? Do you want the first one? What do you want? Also, it said here, you may not use the same element twice. And so imagine the target number is 8, or let's imagine the target number is 4. Then 2 is in here, and if you use that twice, then you can technically sum 2 and 2 and get 4 if the target was 4. But they're saying that it's no. So if the target was some number that you can duplicate within this array, they want you to make sure that you had 2 of them. One other question that you might want to ask your interviewer is the number ordered? And this is already me thinking about some strategies going into the game. But see the example that they gave you. Your interviewer might give you the exact same example. They might give you one without duplicate numbers. They might give you one that's perfectly ordered. And honestly, for this question, if the array was perfectly ordered, then you could use a totally different strategy for it. For example, if they say that yes, it's always going to be ordered, then you could have 2 pointers. One pointer starting to go up from the right, one pointer starting to go from the left. Okay, so this is the right, 15 is the right, 2 is the left, and pretty much say like the target is 9. You could have had one pointer at the 2, one pointer at the 15, and add those 17. That's too much, and so you would bring in the right pointer, 2 and 11, 13. That's still too much. Bring in the right pointer, 2 and 7. That would be your answer. And if those pointers ever collided, this is a impossible case. Although for our purposes here, it says that it will always have one solution, and so that's another edge case that you might have asked your interviewer, but this description answered it. What if there are no solutions? Is that even possible? And also, this direction here, given an array of integers, you might have also asked that question. are there any bad values that could be passed in? And if there are bad values, then you want to do more error checking. But thanks to this description, array of integers, so we know that it's going to be a number, always going to be numbers. We're not going to be given some random strings, so that, I mean, if you're given random strings, you try to add stuff, it's gonna be weird. And so before you even jump into those questions, you want to kind of ask your interviewer these edge cases. That way you could either prove to them that you care about these situational things that can break your code, and that you are aware of the fact that code can be fragile and it's up to you to kind of make it robust. And also, if they say, no, we're not sure if it's always going to be integers, it's a chance for you to show them how you can like incorporate error checking into your code. Usually interviewers are cool with error checking in the form of just if-else statements, where if a value is not a number, then like exit out the code or give an error code or something like that. But with that said, let's look into this situation particularly. We are not going to be confident that these are going to be in order because it doesn't say that here. But yeah, if it wasn't a possible strategy, the one that I just talked about, the left pointer and the right pointer, it's a good one. But you would need to order it first, so pretty much you need to sort it. And in that situation, you would probably be able to do it with a sort. The best sort you could do gives you the time complexity of n log n. And so the time complexity would be n log n, and the space complexity would be constant. You would not have to have a separate data structure that holds a variable amount of space. But, and you might even want to mention that too, if you can think of the two strategies before. However, so we're not going to use that one. We're going to go with one where we use space, but we're going to have a better time complexity. And this is a great case for those two trade-offs. And let me explain to you kind of what we want to do here today. So we want to add these numbers to 9. And so one thing that we have to also remember is indices. And this is even bolded for us. Return indices of the two numbers that end up adding to the specific target. And so they don't want the numbers. They want the indices. In our example here, the target was 9, and it ended up being the 2 and the 7. They didn't want 2 and 7. They wanted a return of 0 and 1 because that's the 0th index, and that is the first index. And so, so we know that as we go through this array, we want to hold on to the value, and we want to hold on to their index because the index is important. And every time you kind of need to hold on to a pair of information, you want to use a map or an object. And when you don't need to, say for this purpose, or hypothetically this case, if they didn't ask for the indices and they wanted the numbers itself, then the challenge is different. We don't need to return the indices, so now we only have to remember the number. And in that case, you would use a set. A set and a map are pretty much very similar things. They both don't hold the order in which you input it into the set or the map. And they both have constant lookup time, the fastest lookup time ever. So in terms of like, is it in there or not? And so the only difference between those two is that if you don't have a payload is kind of like in a map, it would look like maybe A pointing to the number 2. The 2 would be the payload, so the key and value pair. So if you didn't need a pair like that and you only needed to know, okay, does this have an A in it, then you would use a set. This would be the map, and this would be the set. But anyway, so we're going to use a map in our case today in order to hold on to the value and the index. And what we're going to do is we're going to do this with just one iteration of the array. So we're going to use one for loop, and we're going to go through this array one time. And why I say one time? Well, because for the sake of getting a better time complexity, we decided to sacrifice some space complexity, right? We're going to use a map that is potentially going to be a little under n space. And so we're going to use that to hold on to the number. And every time we go into a number, we're going to look for its pair in the map. And so when we get to the 2, we're going to look for a 7. And if the 7 is in the map, then we're going to return. If it's not, we're going to move on to the 7, look for the 2. If sorry, and if the target wasn't 9, we're going to go to the 11, look for its counterpart. If it's not in there, 15, and we're going to look for its counterpart. And so that's the strategy. I'm going to have the solution up here in a second, and we're going to go over it. All right, guys, I'm back. Just had a coughing fit, so hopefully I'm done with all that. Okay, so this is the solution. I used to say go look for it, go look at it, see if you can understand it. But if you didn't get to a solution for this question, stick around because I'm going to explain to you kind of the choices made here, and of course we're going to do a code walkthrough. And so we described just a second ago that we are going to use a map data structure in order to hold our information, and we're using a map versus a set, although they both have constant lookup time, because we want to hold on to the number and the index. If the question had us not return the index but rather the number itself, we would have definitely used the set instead. It's the right data structure to use, and so that's just the map being constructed there. And we're going to use this for loop. This for loop spans this much. That's the start, that's the end, and pretty much a standard for loop. We're going to start with the 0th index. We're going to start at the very front, and we're going to go throughout the whole entire index. And so, like I said, what we're going to do is we're going to look for the counterpart inside the map. And so let's walk through this example we have here. Right now our map is empty, and I'm going to try to kind of, maybe like on the side here, I will hold on to what it currently looks like. Or actually, maybe I'll do it lower. All right, and this is going to be our pair, maybe. I don't know if we're going to need that, but anyways, our map is currently, we are currently now starting, so we're at the 2, and at this point our map is empty. Our pair, what we're going to look at is target minus nums of I, which means we're going to look at the 0th index, so pretty much this equals to the 2, and so we're going to be looking for a 7, or pair is 7. And we're going to say, okay, if map of pair, so we're looking into this map, if map of pair is greater than -1, return this guy. And so why do we do is greater than -1? I feel like that was for the sake of, oh, okay, I remember why. Because if we said if map of pair, we could confidently we would assume we're either going to get like the value of undefined, or we're going to get an index number. But when the index we get back is 0, which is a very fair case and one we're going to see in just a second, this will, if the map of 2, if we ever try to zoom in on map of 2, we're going to get a 0, and since 0 is a falsy statement, that's not going to work out. And so if you're confused about just what I said right now, you might be thinking map of pair, if it's empty, or if there is no 7 in the map, it's obviously going to return undefined, and so that's going to be a falsy value, so we don't even need to do that. We could just do it like that. However, what I just said was, if we ever try to zoom in on 2, that's going to be a 0, that's going to be a falsy value, which is not what we want. So we know that definitely every index, if it does return an index, is going to be greater than that, and also I feel like undefined greater than -1, that's also going to be a falsy value. So if it is really undefined, we're not going to have to worry about it. It's going to ignore this if and go into the else. And so right now, we're at the 2, and so maybe I'll also do that. We're at the 2, and we were looking for the 7. So we were looking for the 7 in this statement here. We were looking for 7 and its index, and so we got nothing. We got we pretty much got undefined is greater than -1, and since that's a false statement, we're going to go into this else, and maps of nums of I, so maps of 2 is equal to I of 0. So now we're going to get 2 and 0 right there. Now our map looks like that. Go back to the for loop, and now we are at the 7. We're at the 7, so pair is going to be 9 minus 7. That's a 2. And now we're going to look at this pair, map of pair, so map of 2, and there we go, we already have it in here. If it's greater than -1 and this is 0, so it works, we're going to return. So we pretty much got our answer here, map of pair, and so we're going to tap into map of pair again, which gives us the 0, and so we're going to have 0, comma, whatever the I value is, which is 1 at this point, and therefore we get our answer. Okay, cool. So this was a pretty simple problem, I guess. It's the first problem, and it's an easy question. So hopefully you guys understood the power of doing this. Of course, like I mentioned, a couple of other strategies that we could have used. We could have sorted it and then just used pointers from the back to the front, and kind of if those added together was bigger than the target, we're going to move the right pointer inwards, because if it's bigger than the target, we're not going to, if 2 and 15 are greater than 9, we're not going to move the 2 to the 7. That's going to be even bigger. And so if it was already sorted, we could use that 2-pointer method. But if it wasn't, then we're going to have to sort it ourselves, which gives us a time complexity of n log n at the best case. And so we opted to do this. We did only one for loop. That's just the n time complexity. And we used a map, so that's also an n time complexity also. But you could even mention to your interviewer, if you finish this question really fast and this was the only one they had, they might say, okay, hey, let's take a look at the other strategy that you had that uses less space and it takes a little bit more time. And so that gives you a chance to do more. I know for one of my interviews, I finished the question really fast, and the interviewer had to kind of throw different challenges at me, actually like 3 times, because I was able to get the solution for each one of his challenges really fast. And so it is a real situation, and when you do that and when you know that that has happened, you probably know I really did well on this interview, this session at least, and so hopefully that's the case every time. But other than that, I feel like there's not much to go over. I could do this real quick. I'll run it, and we'll submit it real quick. So you can see here, I did this question 8 months ago, and I did it just now, and we are getting a 15.2 millisecond. I got 48 just a second ago, which was greater than 98% of it. In Ruby, you get a lot faster time, which was using the same strategy, using a map. So I wouldn't always rely on this too much. And if you are kind of like taking way too long, always go into the details here. And what will happen is you get to see everybody's solution. And you get to see the best ones. And if this is hard to click, just go to this bottom window and click and drag. Or actually, where do I click and drag? You used to be able to click and drag, but now you can't. Oh, I know, this page is still running. Okay, there we go. Yeah, you can click and drag on this small one to look at the subset, and it'll be a lot easier to click. And so this guy also used like a map version, looking at the complement, like how we did it, and returned it when he got it, and didn't, and added to the map when he didn't. And so potentially, maybe if your computer is fast enough, you get 32 milliseconds. But the best one I got today was 48, and that was still good. Ruby was different. Ruby is a lot faster. Anyways, hopefully you enjoyed this video. Be sure to like, comment, and subscribe, and I'll catch you in the next one. Bye.